This is Kevin Trainer. I'd like to welcome you to my tutorial demo. This tutorial demo is associated with Chapter 6 of the Murach MySQL book, second edition, and Chapter 6 is entitled How to Code Summary Queries. And we're going to explore the same database that I have you using for your exercises, the My Guitar Shop database. So just to refresh your memory, I think in the earlier demos I introduced an EERD diagram in which we saw the design of the My Guitar Shop database. And because we're trying to do summary queries, we're going to try to work on some data that can be summarized. Okay, and the kind of summarizing that we can do is we can get a sum, we can get an average, we can ask for the min, we can ask for the max, we can ask for a count of rows. Okay. Now, for the most part, I am going to do the sum, and I'll leave it to you to prove that you could do the same kind of manipulation with the average or the min or the max. But I just want you to see one of these in action. And what we're going to do is we're going to start with just the orders table. Okay? The orders table has a couple of numeric fields, ship amount and tax amount, as you can see here. That could be added up. Okay, so we would be able to sum them. So we want to see how that behaves. And then once we feel that we've fully explored that, then we're going to do queries that involve a join of orders and order items. In an earlier tutorial demo, I pointed out that the orders table doesn't have a total on it for the merchandise amount for the order. Okay, and this is pretty typical of a properly normalized relational database, because in a normalized relational database, we try to squeeze out all the redundant data. So we don't keep the total of the merchandise on the orders table, because you can look at the order items and you can sum them and do a little math and get the total of the merchandise on the order. So we're finally going to be at the point where we can come up with a query that can show us the overall order total, including the merchandise amount, tax, and shipping. Okay? And while I'm doing that, I just want to point out in your exercises, there are times when they ask for you to calculate the merchandise amount and don't ask for a tax or a shipping. So try to read the questions as closely as you can. All right, that's enough of that. So let's go and let's take a look at some of these queries that I've worked up. Okay, so I'm going to begin with a couple of these that are in just the orders table. So we're going to have a list of rows in orders without an order by clause. Okay, I want to make a point here that I've made before, but I want to make sure I make it again. Okay. Isn't this interesting? Okay. That just about fills it up. How about we do that and then we maximize it. Yeah, that's looking good. Just what I wanted. And now we'll connect. And now we're going to open up. Let me squeeze this over. We're going to open up my query. Okay. And this is a list of rows and orders without using an order by clause. So this is it. I've got to use my guitar shop because I consider that a best practice. And then a pretty simple select. Select all columns from orders. No order by clause. Okay. And if we run this in our, I'm sorry, I highlighted something. As soon as you highlight something, the left lightning bolt only runs what's highlighted. So run the whole thing. So here we see we have, let me give us a little more room. We have a row for each one of our orders. There are 9 of them. The order ID goes from 1 through 9. Okay, and then we have all of the columns, the customer ID, order date, ship amount, blah, blah, blah. And as you can see, they're coming out in order of order ID, even though I didn't ask for it. And I just want to point out that that is an accident of our particular implementation of MySQL. Okay, so MySQL is, at least this particular implementation of it, is kind of polite. And if it kind of stores the rows in the order that you inserted them, even though it doesn't have to. And then when we do a query, it returns the rows in that same order again, even though it really doesn't have to. So don't do this. Okay, this is a bad practice. Instead, let's go to O1B. Okay, and we've done the same thing. We've just added order by order ID. Okay, so we had to pick an order, and we did. And let's run it. And we get the same results, but this is a better practice by far. Okay, because we could take our data, we could take our query, and we could move them to some other product, perhaps even some other implementation of MySQL, which didn't have this kind of accidental order to it, and yet we could rely upon the order. Okay, so in your average situation, in a query, you want to have when you're doing a select, you want to have an order by clause. Okay, so it hasn't gotten to the summarization yet, but I just I wanted you thinking about it. Okay, alrighty. Now let's look at the next one, which is C, a list of orders showing the amount columns. Okay, let's see that. So still not summarized. Okay, we don't have the word sum, we don't have average, we don't have any of those functions in here. But typically, if we're going to use, especially sum, we're going to want some amounts to sum up, right? Or some counts to sum up. So let's run this. And here we can see with our 9 orders, and I can't emphasize enough how important it is to come to understand the data in your database. Now, I will say that perhaps you can come to know it too well and rely on kind of accidental relationships in it, okay? But so long as you don't do that, I don't see any harm in knowing the data that's in your database very, very well. Then I think you're going to know intuitively when you get a proper result set compared to one that's missing a row or 2 or 5, or has an extra row or 2 or 5. Okay, so here we've got a row for all 9 of the orders. That looks good. We have the customer ID, and then we have the ship amount and the tax amount. Okay? All right, that looks good. All right, what do we do from there? Well, let's go to number D. Summarized order. Note there's misleading stuff. Okay, so let's look at this. So we are summarizing the order. How are we doing this? Well, we're selecting from orders, okay? And you will note that I don't have an order by here right now, okay? And I'll explain that in a minute. But you know what a lot of people do, and I haven't really mentioned this in my tutorials so far. The placement that I have for the semicolon, where it's on a line all by itself, you'll see some people do that. It makes it a lot easier to find, okay? So if, for instance, you had an order by and you got rid of the order by, well, a lot of times the semicolon will go with the order by. And now you don't have a semicolon there. And I think it's always good practice to end a statement with a semicolon, although it's not absolutely required unless there's a statement that follows. So this is a pretty good practice that I just wanted to show. Okay, so the first 2 columns are not summarized. Then we have a count of asterisk. Then we have the sum of ship amount, the sum of tax amount. Okay, let's give this a run. Sorry, I had orders highlighted again. There it is. Okay, now, maybe somewhat surprisingly, because we have count and sum, okay, and it's just on this single table, all right, we're going to get 1 row in the answer set. So count of asterisk is count all the rows in the answer set. Okay? Well, 9 rows. That makes sense. We had 9 orders. Okay. The sum of the shipping amount is $60. The sum of the tax amount is $120.24. When you look at the values, those look good. So I like to write 3 columns. The left 2 are misleading, okay? Because we combined some columns that we have summarized and some other columns that are not summarized, the database engine had to pick a value for those unsummarized columns, and it appears to pick just the value from the first row. So it doesn't total them, it doesn't average them. So these 2 columns, this order ID 1, customer ID 1, aren't really related to the count of 9 and the sum of the shipping amount of 60 and the sum of the tax amount of $122.24. They're just, the product had to put some answer in here and it picked the value from the first row. Okay? So this kind of select where we mix these in this kind of way is, I think, misleading. Well, how could we change it so that it wouldn't be so misleading? Well, let's look at version E. Okay, so let me open up version E. Summarized orders without the misleading calls. Okay. So now we have a count, we have a sum, they're all summarized columns. Pretty much we're expecting a single row then. Okay. Let's see what we get. And that's what we got. So pretty much the same, but more meaningful. Okay, less less possibility that we're going to distract someone with those extraneous columns that got kind of token values, um, somewhat arbitrary values. It just picked the first one it found and it put them in there. Okay, so I like this answer much better. Now, earlier, I've said a couple of times now, and once within the session that we're in, that we probably, most times when we do a select, we're going to want to have an order by because we're going to want to control the order of the rows in the output. Well, I don't have an order by here. Well, I'm only expecting one row. So there is only one order that I can get. Okay. So, in fact, if I put order by order ID, I think that'll work. It's misleading. Order by order ID. Okay, so let me run that. I get the same answer, but I think it's a pretty misleading change. Okay, sorry, let's open it again. So don't save that, and let's open E without the misleading columns. I like this one. Okay, I like the no order by. So yes, you do want to have an order by when you're expecting more than one row, right? But if you're expecting one row, having an order by is kind of not required and maybe confusing if it subsequently gets, it doesn't get paid attention to because there's only one row. All right. Okay. Let's look at a couple of more things having to do with this summarization. Now, up until now, what we've done is to summarize the orders, right? And we didn't use any group by clause. Okay, so all of the rows were considered a single group. Okay, so when we said we wanted the sum of those columns or the count of the columns, and we didn't have a group by, well, we just got one line. Here, we're going to group by customer. So let's open up F. So we're going to have order ID, customer ID, a count of, when you say asterisk, you mean a count of the rows in the answer set. Okay? The sum of the shipping amount and the sum of the tax amount. From orders, group by customer ID. Okay? So let's do that. Okay? Well, what have we got? Well, you can see that we don't have all 9 of the orders. Okay? And why don't we have all 9 of the orders? Well, that's because some of the customers have more than one order. Okay, I'm sorry, it wasn't group by order ID, it's group by customer ID. I may have accidentally said order ID. Okay, so it's ordered by customer ID. Okay, 1, 2, 3, 4, 5, 6, 7. And if you look at the count, the customer 1 had 2 rows for orders, and customer 4 had 2 rows for orders. Okay, so what has happened is that things have been summed up. So here for customer 4, we've got 2 orders, total shipping cost of $10. I think it was 5 each. Okay, and no tax. Up here for customer 1, we had 2 orders, so we have a count of 2. We have a sum of the shipping, $15. One of them I think was 10, and then the other one was 5. Okay, and then we have the sum of the tax, 122.24. Okay, so we've kind of got what we want here. Now, here is a very fine point. Let me just check and make sure. I'm sorry. I've got so many of these things that are exactly the same. So we're looking at F, summarize orders by group. Okay, now in the product that we are using, MySQL, okay, if you have a group by customer ID, it will automatically assume order by customer ID. Is that true of all relational database products? No, it's not. So we're going to want you to add just a little bit more. We're going to want you to add order by customer ID, okay? And it's not going to change the results that we get. Oh, let's pretty print it too. Okay, so it looks a little different. Let's make it look a little bit different, okay? But where are we? I think we need to go back. Yep, there it is. Okay. So, okay. Now there's one other problem that we have here, and this is the following thing. We have an order ID column. Okay. Now, here where we have 2 orders, and down here where we have 2, which order ID have we got? Have we got the first one? Have we got the second one? Have we got some average of them? This is a misleading column. Like we saw before, when we asked for a column that wasn't going to be summarized in a summary kind of query, we got an answer there, but it's not really a significant answer. So this order ID column is really not a good practice to have there. Yeah, we got a reasonable answer. You know, there were two orders for customer 1. One of the IDs for that customer was 1, but that's all we know. Okay, so this is all pretty rough. Okay, so here I'm going to show you our next one, which is my G. Okay, and interestingly, we didn't put the order by on this either. So let's put order by customer ID, because we just said that's the best practice. And let's pretty print that. Okay, so now we've got the column that we're summarizing on. Okay, so that and the one that we're grouping by, so that's going to be a significant column. If it says customer ID 1, then all the rows that contributed to that will have customer ID 1. We'll have a proper count. We'll have a proper sum. We'll have a proper sum. So I like this better. Let's save this and give it a roll. Sorry. Give it a roll here. And as you can see, we have these in order of the customer ID. We still have the two of them that have a count of 2. Okay. And we pretty much have the same answers, but we're not showing that order ID, which was really a misleading column. Okay, so if you have a summary query and you include a column that you're not summarizing, you're going to get goofy answers for it. Okay, and as long as you're not distracted by them, fine. Okay, there's no big harm in them, but probably not a great practice. Okay, let's look at our next opportunity. What if we would like to get a summary row? Okay, so let's just look at H. Okay. And we have group by customer ID with rollup. Okay. And with rollup should give us one summary row at the end. We don't have an order by. Let's see if that'll work okay. So here we have a little split here. All right. Here's the rollup row. So it's got the total of all the shipping amounts, $60. It's got the total of the taxes. We only have one customer who has to pay tax, apparently, $122.24. There's no customer ID because this is a summary row created by the query. Okay, that's the roll-up row. Now, will we get away with adding order by customer ID? Well, looks like we might. Let's see. It doesn't like that. Okay, so if we're going to do with rollup, we can't have an order by. Okay, so let's give that a save, and away it goes. All right, so we pretty much know we're just doing a single table. Okay, we're going to get either all of the rows in the table, or if we have a where clause, we're gonna have fewer than all the rows in the table. But this is the way we do it. Okay, and we've concentrated on sum, but you could do the same thing for average, and you could do the same thing for min, and you could do the same thing for max. Okay. Okay, so that brings us to H. Let's take a look at example I. Yeah, we'll save that. So let's look at example I. A list of orders showing some null values. Okay. So we're looking at the order ID and the ship date from orders, order by order ID. Sorry. There you go. And here we can see that there are 9 rows that are populated. Okay. 9 orders. We're showing the ship date. 1, 2, 3 of the orders have not shipped yet, so they have a null ship date. Okay? So why am I showing you that? Well, I'm showing you that so we can see how the count function works when we give it a column name. Okay, so here we have a column order ID that has no nulls because it's a primary key, and primary keys have to be unique and not null. And then we have the ship date call, which has 3 proper null values. Okay, now let's just open up the next one. This is my buddy O1J. Okay, and we're going to say that we want the count of the rows. So we want, when you say count of asterisk, it means I want the count of the rows in the answer set, in the result set. Count of order ID says instead of counting all the rows. On each row, look at order ID, and if it's not null, then add 1. If it is null, then don't add 1. So because order ID can't be null, I'm expecting to get the same value for count of asterisk as count of order ID. By contrast, count of ship date should come up 3 short because we have 3 nulls. Okay, so I'm expecting to get 9, 9, 6. Let's see what we get. 9, 9, 6. Okay, so for me, so long as I want to count the rows, and I'm expecting and that's all that I want to do. I just want to know how many rows contributed to this line in the answer set. Okay, then I think the better practice is to use the asterisk. Okay, if you're going to use the name of a column, it should probably be a column that can have null values. Okay, by implication, that's the only reason that it would get any different answer than if you put an asterisk there. So I put this 1 in the middle in for comparison, but I think the best practices are either count of asterisk as it is on the left or count of ship date as it is on the right, because ship date can have null values. And in this case, we decided that we wanted a count of those that were not null. Of course, it depends on what you want, right? Okay, so that was a whole lot. That's all the orders. That's the orders all by themselves. All right, let's take a look at orders and order items together. Okay, so before we do that, let's go back and look at the a typical order. Okay, and a typical order is going to look like this. It's going to have 1 row in the orders table. Okay, it has a foreign key that points to a row in the customer table, so that it has 1 associated row in customers. Okay, it has 1 or more associated row in order items. It depends on how many items are on the order. There's one order items row for every line on the order. Okay, and the relationship between order items and products, each order item is for 1 and only 1 product. Each order item is for 1 and only 1 order. Okay, you've refreshed your memory there. Let's go back and open up a couple more queries and take a look. Okay, so here is a possibly misleading join. Here's a case where I'm joining orders and order items. Okay, and I really would like you to do this because you really have to see what you're going to get. Okay, let's combine those two and see what I get. Well, what do I get? Well, for order 1, where I've got 2 products, okay, so order ID 1, customer ID 1, item ID 1, item ID 2. I find this order ID maybe, Oh, I'm sorry. There are not two products on order one. There's only one. There's only one product on order one. Um, it just happens to have product ID 2. I tell you, you can get turned around. It takes a village here. Okay. On order ID 2, there's a single order line. Okay. Order ID 3, 2 lines here. Okay. So because we matched 2 order items, this result set has 2 lines for order 3. Okay. Well, this kind of makes sense. If you look at what we bought something expensive. It has an item price of $25.17. Something still pretty expensive, item price of $4.15, and there you see the discount amounts. We bought 1 each. Okay, so these are all real numbers. I just want you to point out that the shipping amount and the tax amount are carried on both lines. So does that mean that the tax amount for the order is the sum of 89.92 plus 89.92? Nope. The line appeared twice. You said you wanted to see it in the result set. There's only one row in order, and it has the value on it of $89.92, but it's got to put something on the second line, and it simply repeats it. So see what we got. We got a repeat of order ID. We got a repeat of customer ID. Those don't seem harmful, but these two, if you decided you wanted to add them together, they would be harmful, okay, because they'd be a wrong answer. The proper answer for how much we're paying for taxes on this is $89.92. The same thing for this ship amount. We're not paying $20 for shipping, we're paying $10 for shipping. The item ID and the product ID and the rest of this stuff, I think all makes a lot of sense. Okay, so when you do a join of orders where we have 1 row per order to order items where we potentially have multiple rows per order, there's going to be a row in the result set for every order item. Okay, and if in fact you've listed these columns, you're going to have to remember that we're not adding these together. This is just an artifact, kind of an odd one, of what happens when we do a join. So what could we do in terms of a query that might look a little bit less misleading? Well, here's where I'm going to go. I'm going to go to my B. Okay, so I'm going to have a summarized join of orders and order items. So I'm going to do some summarizing. Okay, so I've got the order ID, I've got the customer ID, I've got the tax amount, I've got the shipping amount. I've got the count. So this is the count of all the rows. So this is going to be the count of the rows that contributed to this line in the answer set. Well, how many lines are going to be in the answer set? Well, group by order ID. Okay, 1 line per order. So all these things that only happened once per order, well, they're only going to appear on 1 line now because we've grouped it. That's good. Then we have a count of the rows that contributed to it. Then we have the sum of what I call the merchandise total. Okay, I know the textbook author calls it something different. He calls it the amount or the total amount or something like that. But it's the merchandise total for all of the order lines. So how do we get that? Well, we take the item price, we subtract the discount amount, we multiply it times the quantity. Okay, and then I also want to show the order total, okay, which is the the merchandise total, which we have to recode because we can't reuse a column alias in a select list. I wish we could, but we can't. So we have to recode that. I simply copied it, plus the tax amount, plus the ship amount as the order total. Okay, so let's give this a run. And I've highlighted something again. Sorry. So we give this a run. And what do we get? Well, very good. We said group by order ID. So we've got 9 lines, 1 per order ID. We have we've got the customer ID. You can see a couple of these repeat. We've got 2 for customer ID 1 and 2 for customer ID 4. Okay. The tax amount. The taxes are not doubled. You can see this $89.92 is only appearing on one line in the results set, on one row. Okay, it makes it a little bit easier to interpret what we're seeing. Okay, then we have the item count. Okay, there are only two orders in the database with more than one order item. This is here on order 3 and down here again on order 7. One has 2, the other has 3. Okay, so these are the proper item counts per order, and this is the merchandise total, and this is the order total, which is the sum of the merchandise total plus shipping plus tax. So even though we didn't keep the merchandise total explicitly in the database as a single value, because we have kept the components in order item, we can, with a very simple query like this, calculate it. And we also didn't keep the order total, okay, but we're able to calculate that. This approach, where we calculate things that can be calculated and we don't store things that can be calculated, this is part of the approach that we call normalization. So this is for the kind of database that we're using, which is an online transaction processing database, this normalization is considered a best practice. So here's how we reconstitute the data. And I think I've got one more thing that I wanted to show you. What if I wanted to limit the lines I got in the answer set to those orders that had more than one item? Well, let's just take a look at this. Okay, so if you want to, after you do your group by and after you do your summarization, if you want to have a test on the results and say, based upon those summarized results, I might want to include or exclude, you can't do that with the where, because the where executes before grouping and summarization. So where do you do it? You do it with the having. So we just use the same expression that we had up here, count of asterisk, which is to say count the rows that contributed to this row in the answer set, and if it's greater than 1, then I want it. If not, I don't want it. So we're only going to see 2 of the summary rows here. So we're going to run it and get 2 of the summary rows right there. Okay, so I'm going to invite you, when you're working on your exercises, to really get to know the database. Get to know how many rows in one of the tables associate with how many rows in the other. just play with this stuff till you own it. And then it's going to be a lot easier to write the queries. So good luck with that, and I'll say bye until next time. Bye-bye.